So first thing we're going to take a look at this week is 2.1, and it's on the zeros of polynomial functions. It basically means figuring out like what number could you plug in for x and get 0 for y. So if you had something like something like that, that's a polynomial. It's a linear polynomial. And if I wanted to figure out what number I could plug in for x that would make y 0, I would just replace y with 0 and solve it. And I would get -4 divided by 3. So the 0 of this polynomial is -4/3. That's the idea of what we're going to try to find. Okay. So let's graph this one. This one's a little more complicated than the one I wrote down. The degree of the one I wrote down is a 1. Okay, that's the highest exponent. The degree of this one is a 3. Okay, so that's a cubic polynomial. And what we want to see is, does that exponent tell us something about how many times the graph crosses the x-axis? Okay, so we type in 2x. And then once you type in the exponent of 3, remember you got to press the right arrow or you're going to keep typing in the exponent. Okay, -3x squared minus 3x plus 2. Okay, so we're going to type in that, and then we're going to do zoom 6 and see what it looks like. If that's not a good window, then we'll adjust it. That window's fine. Okay. So how many times does that graph cross the x-axis? Yeah, Cole.
3.
Yeah, it crosses 3 times. So it turns out that that exponent isn't necessarily the number of times it's going to cross, but it is an upper limit. It could not cross more than 3. It could cross 2, could cross 1. It couldn't do 0, okay, because it's an odd number. We'll talk more about that, but it would have to have at least 1 cross. Could have 2, could have up to 3. Now, if I wrote down the coordinates of each one of those points where it crosses the x-axis, what would the y value be of each one of those 3 coordinates? Yeah?
0.
Yeah, it would be 0. Okay, wherever your graph crosses the x-axis, that means the y value is 0. Now, the way I can show that that is exactly the same as what I have up above is just FOIL it out. Okay, let's multiply that out. There is an advantage to writing it this way. We'll talk about that in a second. But let's multiply that out and see if we get what's up above. Okay. So because there's 3 factors, we're going to multiply the first 2, and then we'll do the other one after. So that gives me 2x squared minus x plus 2x minus 1. Okay, if I make a mistake, just let me know. We'll combine like terms. So we're going to have 2x squared minus x plus 2x is going to give me what when I combine it? About Nick?
Just x.
Yeah, just x. And now just distribute everything out one more time. Okay, so we're going to get 2x cubed. We're going to get x squared. We're going to get minus x. Then we're going to get minus 2x squared minus 2x. And -1 times -2 is +2. All right, let's combine all that together. I'm just going to put it over here. So 2x cubed plus x squared minus 2x squared gives me minus x squared Oh, I must have multiplied something wrong.
Wouldn't it be minus 4x squared? Because it's 2 times 2x?
Yeah, negative 2 times positive 2x squared. Yeah, thanks. So minus 4x squared. I mean, I'll just do that again because I messed it up. All right, make sure the previous step is right because I don't want to mess that up. So we had 2x squared minus x plus 2x minus 1. That looks good. Combine like terms. 2x squared plus x minus 1. That looks good. All right, let's do that again. So 2x cubed. That's going to give me x squared. That's going to give me minus x. Negative 2 times 2x squared is negative 4x squared. Negative 2 times x is negative 2x. And negative 2 times negative 1 is positive 2. Okay, so now we combine our like terms. We've got 2x cubed, we've got a positive x squared, and a negative 4x squared. That's a negative 3x squared. We've got, let's see, we did that one, that one. Negative x and negative 2x gives me negative 3x. Okay, we did that one, and then a plus 2. Let's go back up and see if that's the same thing. 2x cubed minus 3x squared minus 3x plus 2. Yep. So what I had in parentheses here, it was exactly the same thing. Right? So now, let's see if we can find all the spots where the graph crosses the x-axis, the x values. Okay, I already know the y values are 0. Okay, let's find the x values. All right, so we're going to go to second calc, and we're looking for the zeros. So which option do you think we're going to do? Yeah, Ben?
0?
Yeah, we're going to do option 2, which is the zeros. Okay, like most of the things on the screen here, it asks you 3 questions. Pick a point to the left of the 0, to the right, and then do a guess. Okay, I'm going to do the one all the way over on the, I'll do the one furthest on the right. So left bound. Pick a point that you know is somewhere to the left of that 0. Right there. Right bound. Pick a point that you know if I hit enter right now, it's to the right of the 0. Okay, so what I've basically done is I gave it an area that it's going to look in. It's going to look between those 2 dotted lines, and it's going to try to find where it crosses the x-axis. Does it cross the x-axis more than once in between those dotted lines? No. So the guess doesn't matter, okay? Because there's only one place that it crosses because of how I set it up. So you can put the guess wherever you want, hit enter. And one of the answers you get is 2. Which one of those factors could I plug in the number 2 and it would come out to 0? Yeah?
The one on the far right.
Yeah, the third factor right here. By writing the polynomial factored, it makes it a lot easier to see the zeros. Just by looking at that, I can tell you the other 0 is negative 1. That's going to be the other place it crosses the x-axis. And 1/2. Okay. Negative 1, 1/2, positive 2. And you can look at the graph and confirm it. The trick is, how would you take something like 2x cubed minus 3x squared, what we started with, and how would you factor it into that? Well, we're going to learn more about that later on. Okay. For now, I just wanted you to see that if it is factored, it makes it easier to see where it crosses the x-axis. Okay. So, any questions on that so far? Yeah.
I don't get how you got the x number. Like
These 3 x numbers?
Yeah.
Well, so we found 2. We did that one on the calculator.
Okay.
That's the one that we did the second calc 0. And if you plug in the 2 right there, 2 minus 2 gives you 0, right? So the other two numbers are going to be the number that you could plug in here
Oh, to get 0.
to get 0, and then the number you could plug in here to get 0.
Okay.
So it's -1 and positive 1/2.
Do you have to use the calculator? Or can you?
No, if you knew how to factor, if you knew how to get this,
Oh, okay.
you could do it that way. If it was given to you, then it's very easy to do it that way. But the trick would be if I gave you something like this that we had originally, some people might not know how to turn that into what I just showed you, so then you might have to use the calculator.
So you put that into the calculator and then on the graph you do.
Yeah, for now. Eventually, you're going to be able to write that in factored form and then solve it that way.
Okay.
Yeah.
I tried to do some of the multiplication with the calculator and it just came out 0.
What do you mean? Did you type in this?
2x squared plus x minus 1 times x minus 2. It just came out 0.
As long as you put that in parentheses, it'll come out, it should come out, you put parentheses.
Yeah.
So like if I type in that intermediate step, 2x squared plus x minus 1, and then x minus 2, if you watch it, it's just going to trace over exactly what I have right there. So that intermediate step is the same thing, which confirms I had it right up to there. Yeah, it should come out exactly the same. We'll have to take a look and see.
Addition.
Yeah. Show me after, I'll take a look. Oh, that was it. So those three numbers that I found, what were they? 2, -1, and 1/2. Those were the three numbers in this problem that were like A. They were all numbers that if you plug them into the original, you would get 0 for the y value. Anytime you plug a number in for x and get 0 for y, that's called an x-intercept. The number that you plugged in is called a root. It's also called a 0. In fact, some graphing calculators, when you go to second calc, instead of saying 0, they used to say root. That's usually more of like an older calculator. Most of them say 0 now. So the simpler the equation in terms of the degree, the easier it's going to be to find the roots. Okay, linear is generally the easiest, quadratic, it's a step up, and then the one we had on the board was a cubic. In general, solving equations that are higher than quadratic, that can be pretty hard because we don't have there is a formula, but we don't generally know the formula. Like in high school, I don't even know the cubic formula. I know the quadratic formula. But there is a cubic formula that you can solve anything with an exponent of 3. There's also a quartic formula. We can solve anything with an exponent of 4.
There's no quintic.
No, I don't think there is anything above that. So beyond quadratic, though, it starts to get pretty hard to solve unless something special happens. By special, I mean it comes out so you can factor it, or you get nice answers. Okay. Quadratic, we can solve anything because we have quadratic formula. And linear, that's also very easy to solve. If you were to get x by itself here, okay, that's a linear equation. What would be on the other side if you got x by itself? Yeah?
Would be negative b over a.
Yeah, and that's basically the solution of a linear equation. And look how much simpler that is than quadratic. It's way simpler. Just negative b over a. So you can think of that as the linear formula compared to the quadratic formula. Okay, it's only 2 steps. to get the variable by itself. Move the constant to the other side and divide by what's in front of x. All right. So if I were to solve that one for the root, or the 0, okay, setting it equal to 0, what would x equal in this case? Yeah.
Negative 3 over 2.
Yeah, negative 3 over 2. Now think about when you draw a line that's not horizontal. How many times can it cross the x-axis? Or how many times will it cross the x-axis? Okay. Just once. A linear equation has a highest exponent of 1 on the variable. Normally we don't write the 1. But since it has an exponent of 1, that's the maximum amount of times it can cross. And any line that's not horizontal always crosses once.
I'm so
Sorry.
confused on finding the 0 with calculator because I can't figure it out.
Finding the 0?
For the other equation. Like if you didn't have it factored already, now I get how.
Well, if it wasn't factored, you could just type it in like, let's just type in like x squared. I'll just make something up. Actually, I just use the one I already have in there. So I'll just hit graph. Okay, so first of all, when you graph it, you got to get a good window so you can see it. We'll do second calc. We're going to do option 2. I'll do the one on the left this time. So pick a point that you know is to the left of your 0. So if I hit enter right there, it's going to make a vertical line. And I want that vertical line to be to the left of where it crosses the axis. Yep, so that works. Okay, pick a point that you know is to the right of where it crosses the axis. And now the calculator is going to look in between those two dotted blue lines. So the last thing I have to do is hit enter, and the guess doesn't really matter. Just hit enter one more time, and it tells me it crosses at -1.
Okay.
Yep.
And you just do that on the other side too?
You'd have to do it 3 times to get all 3, if you were using the calculator.
Okay.
Yep. You're welcome. And sometimes the answers don't come out to nice numbers. In this case, they did. Okay, let's look at this one. So that's a step up from linear now. That polynomial has a degree 2. What do we call a polynomial that's second degree? Yeah?
Is it a binomial?
So binomial means like how many terms it has. So this is a binomial. If I just write something like 3x plus 7. 1 term, 2 terms. That's a binomial, but it's linear. This is also a binomial, but that binomial is not linear. That one that's a quadratic binomial. Yeah. This right here, that's a trinomial, because it has 3 terms. But the highest degree is a 2, so it makes it a quadratic trinomial. In general, when you draw a parabola, that's the graph of a quadratic, how many times can a parabola cross the x-axis at most? Yeah, Ryan?
2.
Yeah, it can cross up to 2 times. It doesn't mean it will cross 2. It could cross 0, 1, or 2. Think of if the U shape was above the axis. If it came down and just touched the axis, it went right through it. Now, the way you can quickly figure out how many times it crosses the x-axis is the discriminant. That's the part in the quadratic formula that's under the root. That tells you how many times it crosses the x-axis. So remember, it can come out 3 different ways. If this comes out less than 0, does anybody remember what that means? If the discriminant is less than 0, how many times does it cross the x-axis? Yeah?
No time.
No times, because if that comes out less than 0, you have the square root of a negative number. Now you're dealing with imaginary roots. Okay. So if it's less than 0, you don't have any roots. Let me write it that way, actually. So less than 0 means no roots. How about if it comes out equal to 0? Yeah?
One root.
You get 1 root. And what if it comes out b squared minus 4ac comes out greater than 0? Yeah?
2.
You get 2 roots. So that's how you can quickly tell which case you have. Are you less than 0, equal to 0, or more than 0? We did that, the section we talked about quadratics in chapter 1. Now, if you want to go ahead and find the roots, not just how many roots, then you got to do the whole quadratic formula or factor. All right, so this one says to solve, and it says we can do it approximately. That means we could use the graphing calculator to do it. If it said solve and they wanted an exact answer, what are the 2 methods you can, well, there's three main methods, but what's one method you can use to solve a quadratic if you have to do it algebraically? Yep. Yep, quadratic formula. That will always work. And what's another method that works if the numbers work out nicely? Yeah, you could factor it. Yep. But since it does say approximate, probably means the answer is not a nice number, which means it's not going to factor. So we would have to use quadratic formula if they wanted it exact. But let's do it on the calculator. Okay, since we're finding zeros, what's the first thing we have to do with this equation? If we want to type it in on the calculator and do the calculate zeros. Yep.
Move that 2x squared to the other side.
Yeah, if I was going to factor it, I would move everything over with the 2x squared just because I always like this positive when I'm trying to factor. But if I'm going to graph it, it doesn't really matter what side you put everything on. Just get everything on one side. Okay, so now we've got negative 2x squared minus 2x plus 1. Okay, so we're going to type that in. I think it's going to cross twice. If it does cross twice, I will find the intersection point on the right. And then if you guys can do the one on the left, that'll save us a minute. So remember, second calc, 0. Pick a point to the left, hit enter. Right, hit enter. Yes. So one of the answers is 0.366. We'll call it x1 and x2. What's the other answer that you get from the one on the left? The other answer. Yeah, Maddie?
1.366.
One, you mean negative?
Oh, yeah.
Yeah, negative, say it one more time.
Negative 1.366.
Negative 1.366. So that next digit must have been a 5 or lower than a 5.
It was a 0.
Perfect. All right. So there's our two answers. Okay. And approximately, if they don't give you a number of decimals, 2 is usually okay. Sometimes I do 3. I always do at least 2. On a test, I would always say round your answer to, and I'll tell you how many decimal places. Okay. Any question on that? All right, so definitely doable algebraically, but again, we're just practicing the skill with the calculator right now. Okay. All right, so finding roots graphically, pretty much already did this. So let's try another one. There's an older method that sometimes you used to have to use, which was zooming in. So you used to have to just keep zooming in until you got as accurate of an answer as you wanted. Now we don't need to. We just do second calc, and we get the answer. On older TIs, second calc didn't exist. There was no such thing as second calc. So it was a little more time consuming to do it. All right, so this is a cubic. What would I want to do first here to find the roots? Yeah?
Get all the numbers on one side.
Yep, let's get everything on one side. And remember that exponent, that's an upper limit on how many times it could cross. Not a guarantee it will cross. But because that is an odd exponent, I know it'll cross one time. Has to. And this particular one does only cross one time. Never curves back down. Looks like it's about pretty close to 0.5. But we want to get a more accurate answer. So second calc 0. It's about 0.453. 0.453. Now, that's one that I don't know if anybody would know how to solve algebraically yet. Okay? It doesn't look like it's a nice answer. And whether we could solve it algebraically, it depends if we can take this cubic and somehow reduce it to a quadratic. That could be tough to do with this particular problem. So that, at this point, that might be one we would have to rely on the calculator to be able to solve. I'd have to look at it a little more to see the algebra, to see if I could do it. Okay, questions on that? All right, so that was an example of a third degree polynomial. And it looked more like one of these ones on the left. It kind of had a little bit of like a bend in the middle, but it never did a full curve where the slope changed from positive to negative and then back to positive. It didn't do that. This particular graph always has a positive slope to it. Changes a little in the middle, but then it just keeps going. So third degree polynomials have that format. The B, the C, and the D can be any numbers you want, even 0, okay, any real numbers. But the A can't be 0, because if you make A 0, you would wipe out the first term, and then it wouldn't be a cubic anymore. Third degree. So linear, quadratic, cubic, quartic. Those are your degrees that have special names. They might, I think fifth degree, they might call quintic. I don't know if I'm just making that up. I have to check. But really, beyond degree 5, we pretty much just say it's a polynomial of degree 6, degree 7. They don't really use special names. But degrees 1 and 2, they use the name a lot, linear and quadratic. All right, let's try this one. So it's just asking how many solutions does it have. We don't have any shortcut to do that quickly. We just have to graph it and see how many times it crosses. How many solutions could it have at most? Yep. It could have 3, could have 2, could have 1. Has to have at least 1. And remember, we're not even talking about imaginary right now. When I say solutions, I'm talking strictly real numbers that you can see across the axis. We do get into imaginaries, but not in this section. Okay, I'm going to do zoom 6. And how many solutions does it look like that one has? Yep, it does have 3. Didn't ask me to even find them. It's probably the next question. Find the middle one. Okay, So remember to find the middle one. Just make sure when you do your left and right, you set it up so that one is the only one that's between the dotted lines. So pick a point left, pick a point right, and do your guess. Yes?
My calculator shows 0, 0. It's like a similar shape. It's just a different-
So you didn't get 1.55?
No.
Oh, it's minus 5x squared. Oh, you do have minus 5x squared. Plus 6x. Is that a minus sign or is that a negative symbol? Yeah. So you got to make sure you use either the minus symbol, that's when you're doing arithmetic. Like in this case, we do need the minus symbol. And then the negative symbol is what you put in front of a number if you want to make it negative. Okay, how many people got 1.555? Okay, again, because that one is a cubic, whether we can solve it algebraically depends on, well, whether we can solve it using what I'm going to teach you depends on how the numbers are going to work out. But any cubic can be solved algebraically. There is a cubic formula. It's much more complicated than quadratic, way more complicated.
If this is on the test, if your calculator says something like slightly different than the decimal, does it matter? Like 1.554 or 9.
Yeah, that's what mine said. I just rounded it up. You shouldn't, I mean, you should be pretty accurate to like at least 6 or 7 decimals, the same as me. Yeah. Sometimes when it gets beyond like the 7th or 8th decimal, it does change a little, and it's just how the calculator is doing what it's doing. That's okay. All right. So the last thing we're going to look at is find a little bit more on finding complete graphs. You remember that means you're finding windows that fit everything that's important. Things that are important in this section, roots. Okay, where does it cross the x-axis? So remember, when we talked about solving problems in general, the first, I think it was like the first or second week, I had different strategies. Okay, usually when we're solving something, making a graph or using some type of formula are the two main approaches that we will take. And sometimes we use both together. Sometimes we make an equation first, and then we're not sure how to solve that equation, so then we need to use the calculator. Okay, so this problem is going to be about somebody investing money. I would give you this type of formula on the test because you might not know it, and it's not specifically related to pre-calculus. It's more of just kind of like an interest, like a banking formula. And this particular formula is I equals PRT. It's the way that you can calculate simple interest in banking. It's not usually the formula a bank would use. Okay, this is simple interest. They would probably use something called compound interest, but we're going to stick with this one. So basically, Bill has $20,000, and he's going to split that money up and put it in 2 different investments. One investment is going to pay him an interest rate of 6.75%. The other investment is going to pay him 8.6%. So the formula we're going to need to use, I equals PRT. The I stands for how much interest Bill is going to make. The P is the principal. Principal is the amount of money you put in the investment. So if Bill takes and splits the money up, so $6,000 goes in the 6%, and the remainder goes in the 8.6%. The amount in each is the principal. The rate, that's from the percentage, but you always have to change the percent to a decimal. So like 12% is 0.12. Okay, you always have to put the rate as a decimal. Quick way to do that is just to move the decimal places 2 places to the left, which divides the interest rate by 100. And T stands for time. So it says find an algebraic representation of how much interest Bill is going to earn in 1 year. So there's my time. And we don't know how Bill's going to split the money up. All we know is he has a total of $20,000. He's going to put some of it here. He's going to put the rest in the other investment. Since we don't know how much goes in each, we need a variable. And the variable is going to be x. X will represent the amount of money invested in the 6.75% investment. So how many investments does Bill have in this problem? Yep, 2. He's going to be making money from each one of the investments. Okay, with this type of investment, you can't lose money. You can only make money. So for whatever reason, he's got to split it up. He's splitting it into 2 investments. So the first thing we need to do is find how much interest does he earn in that investment. Okay, so let's start with that. So remember, it's I equals PRT. What's going to be the principal for the 6.75% investment? Yeah, X. That's how much money he's investing. What's the rate of the 6.75% investment? But just make sure you give it to me as a decimal. Yeah. 0.0675. And Dex, what's the time for this investment?
1.
Yeah, just times 1, so I don't even need that. So the interest earned in this investment, we're going to write it a little bit more standard, 0.0675x. It's not all the money, that's just the money at that investment. Right. Now let's do the interest at 8.6%. What's the, and I don't want to use a new letter, what's the interest, what's the principal in this account? Yep.
20K minus X.
Yep, exactly. It's the total we had minus what we already invested previously. So 20,000 minus X. My interest rate is 0.086. And again, the time is 1 year. This time, though, we do have a little bit more simplifying. We've got to do the distributive property. All right, so we're going to have, I'm going to put it in like y equals mx plus b. So I'm going to have negative 0.086x. And now I need 20,000 times 0.086. So 1720. Okay, so there's the amount of interest from that investment. Now, to find the total, what would we do with the interest earned from box 1 and the interest earned in box 2? What I'll call it? we're going to add them up. So we're going to add box 1 and box 2. So just combine like terms. Well, there's nothing to combine with the 1720. But I need negative 0.086 plus 0.0675. And there's a formula for the total interest added together. Negative 0.0185x. Okay. Any question on the formula for the total interest? And so far, that's all they said to do. Find an algebraic representation for the interest earned in 1 year. Okay. Well, there's the interest earned in 1 year. All you have to do is tell me what x is, and I plug it in. And remember, that's the amount invested at 6.75%. Okay, so keep that formula handy. We're going to need that in a second. Okay. Remember, when we graph something, especially a word problem, there's a difference between what makes sense to look at algebraically versus within the context of our word problem. So think about the amount of money being invested. What kind of numbers would make sense for x? Yeah. What numbers would make sense?
What positive numbers would make sense?
Okay, I need a little bit more specific.
Like,
20 million?
yeah,
No, couldn't put in 20 million. Yeah?
Anything below 20,000, but also greater than 0.
Below 20,000. What about equal to 20,000?
You could put 20,000.
Yeah. And what about equal to 0?
You could also make
Yeah. Anything including 0 to 20,000. Okay, those are the only values that would make sense for x. You can't go negative, and you can't invest more money than you have. Okay, so I want to figure out how much interest did Bill earn, or how much did he invest in each account if that's the amount of money he earned. So this 150910, what formula would that get plugged into over here? Yeah?
That get plugged into total interest.
Yeah, that's going to get plugged in for I in the total interest formula. Now, if I wanted to do it algebraically, I just fill in $1,509.10 where I just circled, and then solve. Okay, but we're gonna do it on the graphing calculator. Okay, so remember, to do that on the graphing calculator, you're going to use, you could do it a couple different ways. Let's fill in $1,509.10 for I, and that's going to be Y1. 1,509.10. So we're going to have a line that marks the interest. Then we're going to have another line for what's on the other side of that equation. Negative 0.0185x. And what do you think we're going to look for once we set our window and hit graph? Oh, Clover, what do you think?
where Y2 crosses Y1.
Yeah, we're going to look for where the two lines cross. So we're going to think about our window a little bit. Okay. We already talked about the x's, 0 to 20,000. Okay, y is the money, or is the interest that you make. What would be the, like, common sense, I guess, what would be the types of numbers you would not want to use for y min? Yeah?
Negative.
Yeah, we don't want to use negatives. That wouldn't make sense here. What do you think we should set our y max to? Yeah. Well, 20,000, sorry, 20,000 that's the x. So that's the amount of money that we can invest. The y max is the amount of interest we're going to make. But look at the equation for total interest. That kind of gives you a hint based on a characteristic of that line you're drawing. You need to set your graph at least this high or you're not going to see this special spot. Yeah?
If it starts at 17,000.
Right. It has a y-intercept of 1720 and it has a negative slope. So it's going to be going down from 1720. So you need, I would set your y max maybe 1800. Okay. That should be perfect. Okay, so there's your line for your interest. There's your y2. And now we just have to see where they cross. Okay, last week, did we do intersections on the calculator? Second calc intersect? Yeah. So they intersect and x is 11,400. Let me put that over here. Okay, so we have the information we need, but now we have to answer the question. How much did Bill invest at each interest rate? All right, let's start with the, what was the first one, 6.75%? Is that the first one? Okay. How much money was invested at the 6.75%?
This is the equation that we got left with, is that?
So we need a number now. We need a number with a dollar sign on it. Yep.
11,400.
Right. We just solved for x. X equals 11,400. If you go back up, it says x is the amount invested at 6.75%. So you always have to remember what x was. Okay, so that's 11,400. And now the other investment, I think that was 8.6. Yeah, 8.6. How would I figure out how much was invested at 8.6? Yeah.
You would just subtract 11,400 from 20,000.
Yeah. So we just subtract that 11,400 from 20,000. And that leaves me with, is that 8,600? Yeah. So 8,600. And that's how much money was invested at each interest rate. Yes.
I missed what they put into the calculator to get those final numbers.
To get, so to get the 11,400, so we did intersect. Y2 was the negative 0.0185x plus 1720.
I tried that and I got x is 1,100.
And you use the negative symbol for the number, not the subtraction sign.
Yeah.
And for Y1, you put in the
1509.
1509.1.
Yeah.
All right, let me take a look at it and see. But yeah, if you plug in those, you should get the 11,400. Okay, but I'll take a look. Any other questions on that? Okay. All right, so I think that's a good place to stop. So remember, on page 88, we're in the middle of a section right now. Okay, so the first page, page 82. Some of that is just steps you have to show on the calculator, finding roots. If they ask you to find a root, you just have to write down the answer. You don't have to write down the steps like I did second calc. You don't have to tell me that. And then page 88, that's the stuff on the interest problem. I think 31 to 34, that's an interest problem very similar to the one we just did in class. All right, so take a look at that tomorrow. And then reminder, I'll be after school Wednesday because this week our test will be on Thursday.